stream marker. And then hopefully that adding the stream marker worked, and now I can change my stream info. If I can figure out how to do this, I have to go to my dashboard and look at what my, learning ECS by making a roguelike. Okay, and done. Okay, stream info updated. All right, so now I need to reset my brain here because we were working on Wavefunction Collapse yesterday. And let's go to that. We were in the middle of doing these things. We got the new waveform collapse code. We modified this to include it, right? And so we were in here working on this. All right. We did all of this. We did all of this. We've got the waveform collapse stuff. We've got the builder, and then we started doing this here. And then we ran into the problem that the display wasn't working, or I hadn't done this background thing, which looks really neat, but it's only it uses Rex paint files, and we had to go through the steps of pulling that in. All right. So we got the random builder, we got the source image, right? And I've got these two things now, so we can embed these resources in the Rex assets. Okay, and this was WFC demo 1 and WFC demo 2. Right, and then down here we do the same thing. Oh, we got to change these. WFC demo image 1. Oops. And 2. Oh. And 2. And change these files. And then I guess we don't need to add it here. Finally, we should load the map itself inside Waveform Collapse. We do this to load the map. I'll make a new file called image loader. Okay. Image loader. And image loader has a reference to XP file and super map and tile type. I don't know if those will work. We'll find out. Okay. Load Rex map. New depth I32. XP file. XP file map. We don't have to declare it as a map, right? Map, new depth. So we've created our map for a layer in XP file layers. In 0 layer height. X in 0 layer width. Let cell equals layer get XY unwrap. X is less than the width. And Y is less than the height. Then we will get the IDX of the location. IDX equals map XY IDX X as I32 Y as I32. I wonder what it is then if I have to set it, do a map width as use size. So it's comparing it as use size. So that's must be what those are, and then we convert them to I32s there. And then we match cell dot character. If it's a space, map dot tiles index is equal to tile type floor. And if it's a hash, then map tiles IDX tile type wall. And if it's anything else, we ignore it. Like that. This is almost Lispish in the parentheses stuff with the closing brackets. All right. So that's loading the Rex map. Now we can modify our build function to load the map. Okay, so let's pull this up. That would be, so this random number generator, and then we just say self map load Rex map. RLTK Rex XP file from resource. Oh, this is the, and we give it the name of WFC demo 1. I'll just copy and paste that. Oh, I missed the quote. Unwrap. That looks right. And then we get starting position, blah, blah, blah. Okay. So that should set the map. And then we have to use the image loader. Okay. Do we? Let's find out. Yep, not found in the scope. Okay, so we say use image loader. Oh, mod image loader. And that should be an arrow. And that worked. So let's build that. And it should show them. I'm not putting pub in front of these. We're just using them, but not exposing them to outside of the module. Right. So now if we do a refresh, I think we're using, yeah, the Waveform Collapse builder, according to this line here. So we should see that map, right? If I hit refresh, there it is. Did you see that? Boom. Just for a second, but it shows up. If I begin the game, we should see, oh, it's a little too, there we go. A little too small. Right? But it's there. So we basically built a map using Rex Paint image. So now, if we wanted to, we could go into Rex Paint and generate an image with spaces and hashtags and generate the full map. Down here should be the smiley face somewhere. Is it up here? Yeah, this is the smiley face. Yeah, look at that. Okay, that's pretty cool. And that was a lot less work than I thought it was going to be. But we're only like a fifth of the way through this thing. Yeah, it is very nice. Thanks, Nock. All right, so carving up our map into tiles. Oh, we discussed earlier WFC works by carving the original images into chunks/tiles and optionally flips them into different directions. It does this first part, building constraints. All right, we'll start by picking a tile size. We'll call it chunk size. And start with the size of 7. Because that's in our second map. Okay, so we have to remember to change that to 2. Yeah. Second Rex demo file. We'll also call a function we write in a moment. So there's chunk size and then build patterns. Okay. Git status. Let's just check this in because it's all working. Git add source. Git. Right. Oh, Clippy. Keep forgetting Clippy. All right. What's this saying here? You should consider adding a default implementation for Rex assets. Okay. Warn Clippy new without default. So we can actually turn that off, and I think they had that in here. Yeah, allow. I'm not a fan of doing that, but okay, nvim rex assets. Let's just put that there. Did I not hit copy? Copy, paste. There we go. Okay, git commit. Load a map from a file and generate a level from it. All right, let's push that up. Okay, so now we'll go back here and do this part. Down here in build, after we grab the map, we're going to change this to map demo map 2. We're going to set a const chunk size. Oops, into k size. 32 is 7. And we load the map. We take a snapshot. And then we let patterns, build patterns, submap, chunk, size true and true. I'm just going to turn up the volume on the music a little bit because it's too low for me. There we go. Okay. There we go. Hopefully you guys can hear the music. It's hard to tell when you're doing streaming how it sounds going out the pipe. All right, so this is build patterns. Ooh, this is complicated. What is this doing? We're creating a new file called. Oh, you can't really hear the music. Yeah. The problem is when if I increase the volume, it tends to decrease my microphone volume. It's a little quiet. Okay. So I just increased it on the loopback code. Hopefully my voice didn't just suddenly get drowned out. All right. Also, hi General Nova. Good to see you again. Let's see what we can do here with build patterns. So we're creating a brand new file for this. It's up here somewhere. I'm too lazy to type all that in again. And this is just called constraints.rs. I'm going to grab the tile type in the map. And use standard collections hash set. All right, build patterns. We'll take a map, chunk size. It's hard for me to type for some reason. Include flipping and dedupe. All right, so. Oh, and it returns a vec of tile types. Okay. And it has to be a public function. And it is. Okay, good. So what is this doing? It's getting the midpoint of the map. It's initializing a new patterns, which I assume is what's going to get returned at the bottom. Yep. My voice is fine? Good. Thank you. All right. So we're going to loop over every chunk, 0 to chunk Y. We're going to loop over the upper left-hand quarter of the map. Grab a new vector of tile types. And what is this? CX times chunk size. cx plus 1 times chunks. Oh, okay. Oh, I see. Okay, it's not the quarter. It's we're dividing the map width by the chunk size. Right, and so this just grabs a chunk from the map, and then this just generates a pattern from that chunk. So it's basically copying everything from map tiles into the pattern. It pushes the pattern into the pattern list, and then if we include flipping, then we'll do a horizontal flip and a vertical flip and a both-way flip. And there's a dedupe, but I don't see it being used here. Maybe that's coming later. Oh no, it's right here. If dedupe, pre-deduplication, there are so many patterns. We put them all into a hash set and then log it into. This is patterns extend, right? So is that adding? Wouldn't that just add all the patterns that are generated here and then a list of patterns, an additional list afterwards? Oh, yeah, patterns drain. Okay, I missed the drain. Interesting. So that just drains the entire patterns list and basically clears it out as it collects it into the hash set. That looks neat. All right, so let's get started with this. Chunks x divided by the chunk size, and chunks y divided by, sorry, the height divided by chunk size. What did I do wrong? H-E-I-G, H-E-I-G-H-T. That's what I did wrong. I could tell something was wrong because they were both the same length. And I knew that height was longer than width. Okay, for cy and 0 to chunks y, and for cx and 0 to chunks x. Right? So this is the normal orientation. Back tile type. Back new. We might not need this. This might be redundant because it might see that we're pushing tile types here. Rust is usually pretty smart about that. Start x, cx times chunk size. And then we'll do start y, and cy times chunk size. And then let end x is cx plus 1 times chunk size. And let end y be cy plus 1. Okay, for y in start y and y, start x. I'm going to be repeating this code a few times. Let index map xy idx xy pattern push map tiles idx. Right? And patterns dot push pattern. So we generate a new pattern here and we push it here and then we do this. And then we're going to create a new one here each time. Right? So we reset it when we do this part, when we do the flipping. All right. So if include flipping, and then that's that whole section there. And then we have the dedupe. If dedupe, that, and then patterns. Like that. Okay, so it's a bunch of identical code here. Flip horizontal. Pattern equal back new. Getting rid of that comment is Control U, which is maybe Control W would work also. It's kind of not in my muscle memory yet. I'm going to do this, indent it, and then instead of this, we're going to do end x of x plus 1 minus x plus 1, like that. So that flips horizontal. right? And then we do a patterns push pattern. And then let's just copy this. And we flip vertical and then flip both, right? And vertical flip is just the opposite of this thing. It's x and y minus y plus 1, right? And then flip both is just going to be both. Like that. All right, thanks, Knock. I'll see you next time. All right, so what have we got? Patterns push. So we pushed all the patterns, and now all we need to do is the dedupe part. RLTK, console, log, format, log n, format, pre-dedupe. There are patterns. Patterns.len. Yep. And then let set hash set vec tile type is patterns drain dot dot collect. I don't know what this means in Rust. I mean, I know it from here, right? And I also know that in match you can use that to specify a struct match, but I didn't know you could use it as a function argument to mean all of everything. And then console log, post dedupe, there are that many patterns. Right? Okay, and now we need to import this in our waveform code. Waveform collapse code, right? So we need to say mod constraints, what's it called? And then use it. Error check, 11 errors. Pattern, oh, because this, it should be patterns with an S. And that might take care of a bunch of the errors, right? Yeah. And then I misspelled hash set on line 65. Hash set. Anything else obvious? Not that I can see. So that got us down to 4 errors and Y. Extend has 1 T. Collect. Oh, that probably failed. No? I'm going to say that probably failed because of the trait EQ is not implemented for tutorial map tile type. Okay. So I guess we pull up map.rs and implement EQ. Still 1 error. The trait hash is not implemented. For tutorial map tile type. Can I just add that? Okay, well, we got 2 warnings. But it compiled, which is the good news. Blocking waiting for file lock on build directory. What did I do? Is that my nvim? Let's quit out of that. Yeah. It's unused. Oh, okay, yeah. It's unused because we didn't waveform. Yeah, we didn't use it yet. We just initialized it. Okay. So we got this working. That's good. And I think we understand it. I went through the code before I read this stuff, but I think we understand it. We're just flipping horizontal, flipping vertical, and flipping both here. And all we're doing is copying out chunks of the map there. So that works. And then render pattern to map. That's what, oh yeah, look. Yeah, we have to add equal and hash. For this to compile, we have to make tile type know how to convert itself into a hash. So equal, maybe equal was already there, but we just added hash. This code should get you every 7x7 tile within your source file, but it'd be great to be able to prove that it works. Trust but verify. So in constraints, we'll add another function called render pattern to map. Okay, so we go here, constraints. Wow, I have to type the whole thing in to get there. That's bad. That's why I want the target not to be in my FZF thing. There must be some configuration thing I don't have set right. Render pattern to map. Pattern is a vec of tile type. And then chunk size is an I32. And we have a start X and start Y. Right? And it doesn't return anything. So we start at 0 for tile Y in 0 to chunk size, and for tile X in 0 to chunk size. Let map index is equal to map XY index, start X plus tile X and start Y plus tile Y, map tiles, map index is pattern I. So we're just copying over. And then we're setting visible tiles to true. That's interesting. Oh, don't forget the I plus equals 1. So this is pretty simple. Iterate a pattern and copy it to a location on the map, offset by the start X and start Y coordinates. Note that we're also marking the tiles visible. This will make render display our tiles in color. In color. Okay. Now we just need to display our tiles as part of the snapshot system. In Waveform Collapse mod.rs, add a new function as part of the implementation of Waveform Collapse Builder. It's a member function because it needs access to the take snapshot command. So RenderTileGallery. Okay. Waveform collapse right there. So we're going to add a new member function here. And it's called RenderTileGallery. It takes a reference to a vector of tile types. And the chunk size. Okay, we're creating a brand new map here. So that's different to this one. Counter equals 0. Mute Y equals 1. And while counter is less than the length of the patterns, render pattern to map. Okay, and then we're going to increment X past the chunk size, or X up by 1 plus the chunk size, right? There's that F1 key again. Stop that. All right, and then if X plus chunk size is greater than self-map width, then we're going to move to the next row. Well, this seems complicated, right? X equals 1, Y plus equals chunk size plus 1. And then if we're past the end of the map, this makes sense. Then we'll move to the next page. Self take snapshot. Self map. Is map new. And then we reset X and Y. And counter plus equals 1, and then we can say self take snapshot. Okay, so it's basically each snapshot page is going to be one set of the patterns, right? So we call build patterns, and then we say self render tile gallery. So that's up here. Where is it? So here's like patterns, right? And then we say self render tile gallery with the chunk size. Also comment out some code so it doesn't crash from not being able to find a starting point. Okay. Hopefully this won't crash. We do have a failure to render pattern to map. That should be in... I thought that was in constraints. Oh, it says help consider importing this function. Yeah, I got use constraints star at the top here. What did I forget? Constraints, waveform, constraints. Oh, I didn't make it public. So it wasn't that I needed to import it, it needed to make it a pub, like that. Okay, so that worked. So let's build that and see if we get this tile gallery instead of this smiley face. Not really. It looked like it only... I saw 2 there. I must have a bug in my... no, not this one. In waveform collapse, there must be some issue here. X plus equals chunk size, right? What did I mess up? Counter is 0, X and Y is 1. Our counter is less than the length of patterns. We're going to render that, right? X plus equals chunk size 1. If X plus chunk size is greater than the map width, move to the next row. You saw it was just putting in like 5 or 6 patterns. It wasn't doing all of them. Y plus equals chunk size plus 1. That's greater than the map height. Take a snapshot. Reset the map. Reset the XY coordinates. And then counter is 1. Alright. I mean, it looks like the same code. But for some reason it's doing... Wish I could freeze it. Oh yeah, pre-dupe there are 264 patterns, post-dedupe there are 7 patterns. Okay, that's why only 7 patterns are showing up. But in here, they have a whole bunch. Oh, it'll show you the tile patterns from map sample 2. Notice how flipping is giving us multiple variants of each tile. If we change the image loading code to WFC demo 1, we get chunks of our hand-drawn map. Okay. I was confused because I was looking here. But if we change this to 1, right, and build that, then we should see this kind of thing. There we go, and hit refresh. Yeah, okay. So that did show us a bunch of different patterns. All right. It goes by pretty quickly, but that's okay. So next up would be building the constraints matrix. So we have this code here. Let's clip E and format. Interesting. Writing vec instead of slice involves one more reference and cannot be used with non-vec based slices. So help change this to slice and change that to a slice. Okay. This is in constraints.rs, and this is in mod.rs. 82 and 100. All right. Let's see if that. Let's see how that works. If I do this, and line 100 is they're saying, what was it? Oh yeah, so slice of a vector. Like that. Does that compile? That checks, does it compile? I mean, it should, right? If it checks, it should compile. Yeah, so I'm not sure what advantage we get, but it sounds like we can use it with vectors or slices if we give it that that signature instead of a double vec signature. We can just use a slice signature, and all the other code stays the same. So add source, slice up chunks of map and show them. Let's push this up. Where's my, that's the wrong repo. Where's my repo here? And it commits 11 seconds ago. Yeah, that was this one. Okay. Yep. All right. So I should have time for a little bit more. So building the constraints matrix. Now we need to begin to tell the algorithm how it can place tiles next to one another. We could go for a simple what's next to it on the original image algorithm, but that would ignore a key factor in roguelike maps, connectivity. We're far more interested in the ability to go from point A to point B than we are in overall aesthetics. So we need to write a constraint builder that takes into account connectivity. We'll start by extending builder in mod.rs to call a hypothetical function we'll implement in a second. It might take me more than a second. If I'm using Linux, I can change the linker to LDD to speed up your. Yeah, I'm on Mac. So if there's a, if you have suggestions for Mac, that would be great. But I'm not an Arch user, like Togglebit. I'm afraid I'm not brave enough to use Linux and deal with the sysadmin side of things. It would be good to learn that though. No need to apologize. I just am not as hacky as, or hackery as some are. All right, so waveform. So we have patterns as build patterns, self render tile gallery, and then we're going to do say let constraints patterns to constraints patterns and chunk size. All right, so we'll see how far we can get with this today. I have to end in about 15 minutes. And now we're going to add a new file called common. Yet another new file. Use super tile type. And we're going to derive partial equal hash and clone for a new struct called map chunk. Okay, and then we have this. All right. Ooh, this might take a while to get in. This might take more than the 15 minutes I have allocated for today. Pub pattern, tile type, pub exits is a slice of bools, a four-way slice of bools. Has exits is a bool compatible with. So what I'm guessing is we're going to check the edges for exits and see how they line up with other tiles, right? So we only put tiles next to each other if those tiles can actually, a player can move from one tile to another. XI32, YI32, and it returns a U size. And this is just Y times chunk size plus X as U size. All right, that's simple enough. And then we'll go to constraints. So we'll save that as a new file. Waveform collapse constraints. And we're going to create a new function here at the bottom. Patterns to constraints. Vec tile type. Chunk size. I32 gets vec map. Chunk. Okay. And I guess this is our return value, right? Chunk equals vec new. Right? And then we're going to go through all of these things. Wow. Okay. So we're going to create a new map chunk. We're going to push false for all of the exits. Exits is a vector of a four-way vector of Boolean. So I guess each side is going to get a list of possible exits from that location, right? And then number of exits is 0. We go through the chunk size using X. We check north, south, east, and west and determine whether or not, so 0, 1, 2, and 3. And we index into that vector and we set it to true if it's a floor. Yeah, this seems ripe for refactoring, but that's okay. And then if we have no exits, then we say that there's no exits from this tile. So that means we generated a tile using our generators that doesn't have any way to get into it, right? And then we push that onto our constraints. And then we build a compatibility matrix. So this is going through and determining whether or not, can the north go to south, can south go to north, east, west, west, east, right? And if the potential exit opposite works, if they can connect up, then we say it fits, is true. And this is another place where we can put a break statement in to stop, because once we have a fit, then we don't need to keep looking at more exits. And so then if it fits, we'll just push it. We can actually just push it here and break, right? And we don't need this extra it fits variable. If it doesn't have any, if there's no exits on this side, doesn't matter. If there's no exits on this side, we don't care what goes there. So then it's compatible with anything. A really big function, but clearly broken down into sections, right? So let me look at that last part where it says if it has any is false. We don't care about adjacency in this direction. So we add J to the compatibility matrix for all directions, just like we did for a tile with no exits. Oh, is that what we did with no exits? Oh, here, yeah. So if it doesn't have exits and the potential one doesn't have any exits, then anything can go next to it. Okay. All right. And that builds a list of constraints. So that will be for tomorrow. Implement this. Okay. I'll put a to-do there so it highlights. All right. So I think I'm going to call it a stream. We did Advent of Code at first, right? I got my answers. I can share on Twitter, which I will do as soon as I'm done with the stream. and I checked out the leaderboards. Did anybody else do anything? I'm still in 8th place there. I'm still in 4th place there, and on Tonklebit, I am still in 9th. Oh, Carson. Good job, Carson. You did it. He'd only had 1 star yesterday. Or earlier today, sorry. He must have been right in the middle of it. Okay. But thank you very much for watching, everyone. I hope you enjoyed the stream. I hope to see you again tomorrow for Advent of Code Day 2 and for more Rusty roguelike tutorials. Take care.